You are most likely watching this video because you are in a class where your professor is expecting you to use computing for some of the course activities. In today's educational environment, it is possible that you may work in several different programming languages as you go through your studies. For example, in an economics course, you might use the R language, but in a subsequent sociology course, you might use Python. In physics, you might use MATLAB or use JavaScript. You might even find yourself programming in multiple languages during the same semester. You will have a much easier time shifting across these different languages and course requirements if you have some understanding of the basic concepts of computing, of the basic actions a computer can carry out. The goal of the video series you will be watching is to explain basic computing concepts and actions and supplement the computational work your professor is asking you to do in your course. There are a number of benefits of understanding computing concepts. It will become easier for you to learn new languages in the future. It will be easier for you to switch between programming languages. It will be easier for you to follow example code and adapt it to solve new problems. It will help you understand problem solutions that are provided to you because you will have better ability to step through those solutions on your own. It will help you develop problem solutions of your own. And it will help you figure out why code isn't working, because we all sometimes write code that does not do what we want or what we expect it to do. What are these basic actions? They are relatively straightforward, and we see examples of them even in day-to-day life. First, there are sequential operations that are executed in order. For example, think about the basic process of writing a paper for a course. Minimally, we hope you go through these steps. You decide on the paper topic, you locate related resource materials, you read the materials and take notes, you make an outline for the paper, you write the paper, you edit the paper, and you turn in the paper. The next basic operation is decisions that determine whether a particular set of operations will be carried out or not. These make it possible for the computer to choose between several operations or between several groups of operations. You make decisions all the time, and we can make the computer carry out that same sort of process. So you can see here two examples. If it is raining, then take umbrella to class. You make that decision when you look out the window in the morning. Or another decision, if class is at 8:30, then get to breakfast by 7:45. Otherwise, meaning your class isn't at 8:30 and probably is later, then you want to get to breakfast by 9. The next basic operation or action is iteration, which refers to repeating a series of operations. Repetition can be based on a fixed count or based on some condition being true. For example, when spreading frosting on a cake, you basically carry out a repetitive process. While cake not fully frosted, so you look at the cake, you see if there's any spots that don't have frosting yet. If the cake's not fully frosted, you will get more frosting on your spatula and spread it on an uncovered section of the cake. And so you can imagine if you put just a little bit on the cake each time, this process will repeat a pretty large number of times. If you put more frosting on each time you spread some, it won't repeat as many times. But the number of times you would go through this process is not predetermined. It is determined by how long it takes to get the cake fully frosted. The next basic concept is creating and naming functions. This is when we group together and name a series of operations so we can later on refer to the whole group as a single step and use it in the solution to a larger problem. For example, we could take our cake frosting iterative process and name it simply frost cake, and then refer to that by name every time you want to frost a cake. All programming languages have ways of carrying out these different problem-solving actions or techniques. Just like natural languages that we speak, each programming language has its own syntax or grammar, and they all have a way to say the same things. For example, these two code blocks will do exactly the same iterative process and generate the same output, but one is a Python version and the other is a Java version. Once you are familiar with the basic computing actions and you know how to carry them out in one language, it becomes much easier to learn subsequent languages in the future. It also becomes easier to think about problem solutions in ways that can be expressed in computer code and executed by a computer. Hopefully, this overview and the material in the subsequent videos will help you with the computing work that you will be doing in your courses.